Hello, fellow adventurers. What brings you to this lovely forest today?
Business.
Business, right. So you're not in search of the golden calculator?
Like we said, business.
Right. Well, if you are in search of that calculator, you'll definitely need this lesson. 9-1, Introduction to Sequences. A sequence is an ordered set of numbers. Infinite means that it never ends. Finite means that there's a limited amount of terms. Term of the sequence is each number in the sequence. In this chart, you can see that there's two sets of numbers. The top is the term number represented by n, and it's also the domain. And on the bottom, you have the term value, which is represented by an, the range. In an explicit formula, it defines the nth term of a sequence as a function of n. This is an example of an explicit formula. You use the ratios and the differences to find the powers and the base. An iteration is the repetitive application of the same rule. You'll need this to pass.
Thank you.
Make sure to get it right.
Okay. Write a possible explicit rule for the nth term of the sequence. So the first thing I need to do is find the ratio or the differences.
The first differences are -10, I noticed.
You're right.
The first differences are constant, so the sequence is linear.
Yes, that's just what I was thinking too.
The first term is 25, and each term is 10 less than the previous.
So I think it would go... Since it's the previous, I do n minus 1, right?
Yeah, that's...
Now I should simplify, don't you think?
I think so.
There we go.
That's it.
Couple.
Yeah, we did it.
Dang nabbit, they got it right!
Thank you. Good day.
Little do they know, they'll also need 9-2, series and summation notation. A series is the indicated sum of the terms of a sequence. Summation notation is seen here. The 5 is the last value of k, 2k is the explicit formula for the sequence, and k equals 1 is the first value of k. Just an example. Summation formulas. There are 3 different ones: a constant series and a linear series, which both need to be expanded and evaluated when you work on these problems, and a quadratic series, which you will need a graphing calculator for. They're all seen here.
Whoa, what is that?
I think it's a force field. Hey, wonder what this does.
Answer this question!
Find the 12th term of the arithmetic sequence.
I know this. Arithmetic sequences and series.
Go.
9.3 Arithmetic sequences and series. They have a constant first difference. The recursive rule is a of n equals a of n minus 1 plus d. Each term in an arithmetic sequence is the sum of the previous term and a common difference, which is d. The general rule for arithmetic sequences is a of n equals a of 1 plus n minus 1 times d. The nth term, a of n, of an arithmetic sequence is given by this formula, where a of 1 is the first term and d is the difference. So if you were trying to find the 8th term of an arithmetic sequence, you'd use the general rule. And so you'd first find the difference, which you can get by 8 minus 3, which is 5, and you plug in a of 1, and you can use the formula to get your answer, which is 38 in this case. Another type of question you'll see is to find the missing terms. And for this one, you use your formula first, but you're going to find d, and you can use that for a of 1, putting in your first term, and for a of n, you put in your last term, and that will give you d. and then you're going to plug it in for each one, since now you know the first term and you know the difference, so you can plug in for n minus 1 what it is. So a of n, a of 2, a of 3, and a of 4. Arithmetic series is indicated sum of terms of an arithmetic sequence. So this can be found using the formula s of n equals n times a of 1 plus a of n over 2, where n is the number of terms and a is the first term, a of 1, and a of n is the number, like, nth term. So for, like, an example, so if you had s of 15, the first thing you would do is find d, which is 9 minus 5 equals 4, and then you'd find a of 15, which is, you'd plug it in, and you have a of 15 and 5, and then 15 minus 1, because 1 yet. You use your general rule here. And then once you have a of 15, you can plug it in because you have a of 15 here.
Answer the question or he gets his head blown off.
Answer this question.
Indicated sum for geometric series. This takes me back to 9-4. Geometric sequences and series. Similar to exponential functions, geometric series have common ratios. The recursive rule for geometric sequences is a of n equals a of n minus 1 times r, where each term in a geometric sequence is the product of the previous term and the common ratio. So you can only use this if you know the term before the one you're trying to find. So for the general rule of geometric sequences, it is a of n equals a of 1 times r to the n minus first, where the nth term, a of n, of a geometric sequence is this formula where a equals the first term and r is the common ratio. So for example, where you'd use the general formula, you would, and you have these terms. First you'd find the ratio, which you can see is, 12 over negative 6 equals negative 2. And you'd have a of 1, which is already 3, and so you'd plug that in into the formula and get your answer. And something different about geometric sequences is when finding the seventh term of a geometric sequence using given terms, it's similar to arithmetic sequences and series, but when you find r, you're usually going to get a positive and negative number. So you're going to have to plug in both the positive and negative r to find the a1, and this will probably give you different a1s. So when you plug it into the big formula with your a1 and your r, you have to use the negative and the a1 that you got from that. So, for this one, if you have negative 5 and 0.032, because that's what you got from negative 5, you might get a different answer than what you got from your positive 5. Something else with this lesson is geometric means, which are the terms between any two non-consecutive terms in a geometric sequence, is found by the formula square root of a times b, if a and b are positive terms with one term between them. A geometric series are the indicated sum of the terms of a geometric sequence. The partial sum of the first n terms of a geometric series is given by the formula s of n equals a1 times 1 minus r to the n minus 1 minus r, where r doesn't equal 1. So that's geometric series, and this is partial sum formula. I know how to do it. I did it! Now let him go!
Oh, rats. I guess you are good at this stuff. I guess I'll have to let him go.
We're almost. No. I think we're almost there.
Me too.
I think we're safe over here.
Where did they go?
I think she's gone.
Close one.
How do we get up?
Answer this question.
Find the sum of each infinite geometric series if it exists.
This may help us. Do you know what that is?
Oh, I remember this. Mathematical inductions and infinite geometric series. Vocabulary. Infinite geometric series has infinitely many terms. When it converges, the sum approaches a fixed number. R, the absolute value of R must be less than 1. The limit is when the number that the partial sum approaches as n increases. When it diverges, the partial sum does not approach a fixed number. The absolute value of R is greater than or equal to 1. Sum of an infinite geometric series. The formula is S equals A1 over 1 minus R1. A1 equals the first term. Mathematical induction is a type of mathematical proof. For the first step, the base case, you show that the statement is true for n equals 1. Step 2, you assume that the statement is true for natural number k. Step 3, you prove that the statement is true for natural number k plus 1. A counterexample is used to disprove a statement. For example, 2n is greater than or equal to n squared. We plug in -1 for both n terms. 2 to the negative first is greater than or equal to -1 squared. 1/2 is not greater than or equal to 1, which makes it a counterexample. Find the sum of each geometric series if it exists.
Answer the question correctly. Let's go. I see the calculator. Here it is, the golden calculator. But it doesn't mean anything. The treasure was knowledge all along.
I can't.